Alright, so sorry for the long delay between videos. College got in the way and I was way too busy to work on anything else. But now the semester is over, so I'm back to working on games. And my newest project is a project where you'll be working in a fast food restaurant making burgers. You'll be receiving orders in the form of tickets and you'll be grilling patties, building burgers, and then sending them out. And just like in a real restaurant, the orders will be items from a menu that can have optional modifications specified by the customers. And each time you complete a burger, you'll be graded on how well you did. And what I have so far is grilling and creating burgers, and also an algorithm for grading the burger you make. And I'll explain that once I get to it. But first, I'm just going to go ahead and show you the first thing you do, which is grilling. And I should mention that the burger that's currently pre-programmed that we're supposed to be trying to make goes bottom bun, patty, American cheese, patty, American cheese, ketchup, lettuce, tomato. But we're going to actually make it a little bit wrong so I can explain the algorithm that grades you and how it works, and explain the score we get. So there are 6 cook levels, ranging from 0 being completely raw to 6 being completely charcoal. And the ideal cook level is 4, and we can tell when it gets to 4 because this middle part will turn a darker shade of brown, like that. Yeah, this is cook level 4, that's what it looks like. And we'll be able to tell when it's completely cooked to level 4 on both sides, because this part right here will become a darker brown, darker than this. Right now it's vaguely equal to this, but yeah, now it gets the kind of brown around the bottom, and then right there, that's how you know when it is completely cooked on both sides to the perfect level. So anyway, we're going to go ahead and start making our burger. It shows up as like a transparent little ghost of the ingredient. You can see a little kind of like a wireframe of where the ingredient's going to go, and it goes blue when it's within range that you can place it. And perfect alignment is where it perfectly overlaps the little wireframe version of it. So let's go ahead and put on a patty, and we're going to make a mistake. We put on cheddar cheese, but oh no, they wanted American. I mean, maybe if we cover it up with American cheese, they won't notice, but of course they will notice. So then they wanted another patty, American cheese, and then, oops, they wanted ketchup. Well, it's too late now. And then what was it? Tomato, lettuce? Oh wait, no, it was lettuce, tomato. Well, too late. So yeah, now we're going to see the kind of grade we get for this burger. And we get a 75, which is the exact score that I calculated. And let me click on this so we can see why we got that score. We got a Doneness score of 98, which in the little graph I made, we actually got a 96, but I actually did a much better job of grilling this time. And the ingredient score, we got a 75. We got an 80, an 80 for inclusions, 75 for exclusions, and 92 for sequence. So you can see that clearly it's not an average. It's taking the lowest of the scores for both the ingredients and for the overall score. And for the neatness, we got a 98. There must have been something I misplaced. I didn't notice what it was. It was probably one of the cheeses. But I don't know. Actually, it might have been... I actually don't know what I misplaced. But anyway, so yeah, we got 98, 75, 98. And of course, we got the lowest out of all of those scores as our final score, and 75, which is a C. And you can see that it's called DINE score, which stands for Doneness, Ingredients, and Neatness Evaluation. So now, I'll just go ahead and explain how the algorithm works. Here is the code for it right here. You probably can't really tell what any of it was, but anyway, this is the verbal explanation. I'll explain it this way first, and then I'll give you the much more helpful visual aid. So the Doneness score is the minimum Doneness score of the 2 sides of each patty and the minimum score of all patties. And the ingredient score, we'll see below. I should also note, the very top and bottom buns are not counted in ingredient calculations. That's because, I mean, they're givens. They're gonna be there. You have to place a bottom bun to start making the burger, and you have to place a top bun to finish the burger, so they're just not counted. So inclusions is the number of ingredients in the correct order that exist in the prepared order, excluding patties, divided by the number of ingredients in the correct order, excluding patties, times 100. And exclusions is 1 minus number of ingredients in the prepared order minus number of ingredients in the prepared order that are not present in the correct order, divided by the number of ingredients in the prepared order, times 100. And the sequence is 1 minus number of ingredients that the correct order and prepared order have in common that must be moved to create the correct sequence, divided by the number of ingredients that the correct order and prepared order have in common, times 100, and that's a minimum of 50, which means that 0 on this scale gets scaled up to 50. And the evaluation for the ingredient score is the minimum of the inclusions, exclusions, and sequence scores. And then the neatness score is based on the average distances of ingredients from ideal locations. Small ingredients, pickles, onions, bacon, and condiments, haven't added bacon yet, are excluded. And again, kind of like with the sequence score, it has a minimum of 50%. And the evaluation is, of course, the minimum of all of these, as we saw. So, yeah, that's a lot of text. Kind of hard to understand, at least if you're a visual learner like me. So, I provided a helpful visual aid. So we're going to zoom in to about this much and go over here. So we can see the correct order. Like I stated, it was patty, American, ketchup, lettuce, tomato. And what we made was patty, cheddar, American, patty, American, mustard, tomato, lettuce. And so the first category we have is doneness. This is a graph that shows what your score is from 0 to 100 based on the doneness level. So we can see that 4 is, of course, the ideal level. And it doesn't drop off very sharply until about here, where it starts dropping off vaguely linearly. Same over here. And so if it's completely burnt, or it's these two cook levels, it's a 0. And we can see that, well, at least in this hypothetical situation, I got a 4.1 and 4.2 for the two sides of this one, and a 4.2 and a 4.4 for the two sides of this one. The 4.1 is about 100%. It's actually 99.75, I think. 4.2 is exactly 99%, I think. Again, exactly 99%, and 4.4 is exactly 96. So the minimum of these two is 99, the minimum of these two is 96, and the minimum of these is 96. So that's why we got a 90. Well, actually, we got a 98 for the grill score, or the doneness score in this. So we can actually go ahead and check what levels I grilled it to. So if I go under Builder Station, I almost called it Burger Station, and there's one patty, 4.3 and a 4 approximately 1, which is like a 99. And then where's the other patty? I must be, there we go. I was going to say, I must be blind. Yeah, 4.13 and 4.19. So that's about a 4.2, I think. So yeah, I guess that the score does make sense. So the 98, wasn't it, for the doneness? Yeah. Can we get that back up, please? Thank you. So yeah, that's how the doneness score was evaluated. Now we've got the ingredients score. So inclusions was at 80% because, well, I'll explain this. Like I said in the text, patties are excluded in the inclusion score, but not in the exclusion score. So the cheese from the correct order was there, the other cheese from the correct order was there, the lettuce from the correct order was there, and the tomato from the correct order was there. So that's 4 out of 5 ingredients from the correct order that were there, which is why we got an 80%. Then the score that ended up being our final score, exclusions, was, okay, this cheddar cheese was not on there, and this mustard was not on there. Those are two things we didn't order, and they make up 2/8 or 25% of the burger we prepared, which is why we got a 75% for exclusions. Then, of course, there's the sequence score, which is one of them. I think it's probably the most complicated evaluation of this entire thing. And so, anyway, you may have remembered that it said the ingredients that it has and that the prepared and correct order have in common. So that's what this is conveying right here. It's drawing lines between all the ingredients that they have in common, and then it's showing just the ingredients they have in common. So we can see that okay, it's really simple to say, but apparently not. These ingredients are out of sequence on the prepared order. And so it basically runs this through a sorting algorithm, and however many ingredients it has to move, divided by the number of ingredients there are in common, of course all -1 and times 100, gives the sequence score. So we had to move 1 ingredient, so that's 1 out of 6, which is like 0.1667. And then we subtracted that from 1, which is 0.8333 times 100, of course, is 83%. But if we had a lot more ingredients out of place, the sorting algorithm would have had to have moved a lot more ingredients. But luckily, overall, it was just 1 ingredient that we had out of order. And the neatness, I didn't have a visual aid here because it's a little bit difficult to kind of show, because I kind of had these orders in exploded view, which is, of course, not how they are in the actual game. But anyway, what it does is it calculates the distance of each ingredient from the center of that little wireframe thing we saw, with the furthest away you can possibly be amounting to 0%, and the closest amounting to 100%. So the fact that I got a 98% must mean that 1 ingredient was probably off by 1 pixel, which is not very much at all, which is why we still got nearly a perfect score for neatness. But of course, our downfall was that we put way too many things on there that the customer didn't want. Even though it was just 2 things, there weren't that many things on the burger. So yeah, the fewer things there are in the burger and the more things that you put on there that aren't there, I mean, the worse of a screw-up that is. I mean, that's just kind of how it is in real life. If you have a really simple order, it's hard to screw it up. So if you do, it's just that much worse. And that's why I chose to go with a minimum out of all the scores instead of an average. Because, like, for example, like I mentioned earlier, a completely raw or completely burnt single side of a patty is a 0. And of course that 0 goes all the way to the final doneness score since it uses the minimum. So yeah, if you get a burger and it's like perfectly built and it's got everything you wanted on it, but one of the sides of one of the burgers is charcoal, I mean, you're probably not going to like it, and you're probably going to send it back. I mean, some people, wow, my hick accent came out. Some people are probably not going to send it back, but that's where the, what did I call it? The tolerance levels come in. I mean, I don't know if you saw the warnings that it had up at the very beginning. You probably didn't, but it said things like neatness tolerance, doneness tolerance, and ingredients tolerance. Their values are assigned but never used. That's because I haven't implemented that yet. But later, I will probably use those tolerances for certain customers that are going to be way more lenient on your score. And there are going to be other customers that are going to be way less lenient on your score. And the further in the game you get, the less lenient they're going to be. And anyway, that's all I've got right now. About the plans I have, I'm thinking that one of the game mechanics is going to be that later in the game, you'll get to add your own items to the menu, and maybe even give them their own names, which I think that would be pretty fun. Imagine making an absolutely ridiculous burger with an absolutely ridiculous name that people could actually order, and you could actually get paid to make. That just sounds really funny to me, and I think it would be a really fun game mechanic. I think that's all I really have planned. It's a really simple game. Really simple concept. And it should have been a really simple execution, but the sorting algorithm was something that was giving me problems last night. The algorithm that I was trying to use, I didn't know what it was called, but it turned out to be called bubble sort. And my implementation completely froze Unity whenever it ran, but if I were to use lists instead of arrays, it would completely freeze my computer whenever it ran. So I took to Reddit and asked, what am I doing wrong? And somebody provided an algorithm that was much simpler that... What do you know? That's a Reddit notification. But it has nothing to do with my post, though. Just a trending thing. And the correct algorithm, I saw it and I'm like, I was working way harder and not smarter. And I kind of felt kind of dumb, but I'm also really grateful to that user. Who was it? I think it was Erratic Dan. So thank you, Reddit user. You have kind of saved me because my original way of quantifying sequence was really dumb. It's just taking the distance of each ingredient from where it's supposed to be, which isn't that fun. Like if you were to take the bottom ingredient and put it on top, well, then that'd be a pretty big dent to your score. But in the new algorithm, that's only one ingredient that's moved, so it's not that bad. And in reality, it probably wouldn't be. Although if it was something like a patty, it probably would be. Although, I don't know. I'm not sure how I would react if I asked for a patty on bottom and it was on the top. I mean, I don't know. It's not important. I don't know why I'm thinking about this. But anyway, yeah, that's all I have for this video. Thanks for watching, and bye.